Well, I am extremely excited to be joined by Srikanth Jagabathula, the CEO of Xcelsa Labs today. Xcelsa Labs is doing some extremely exciting work in AI-enabled EDA, a topic that I just posted about earlier this week, and I'm sure will be a huge topic of conversation at the upcoming AI Infra Summit, as well as is a topic of conversation on a lot of leaders' minds within our industry. So thanks so much for taking time to speak with us today, Srikanth.
Of course. Thank you for having me.
So, Srikanth, for those that haven't heard the name Excelsa yet, they soon will. I'm sure it's going to be everywhere. But can you tell us a little bit about what Excelsa Labs is building and what the big problem you're trying to solve for is?
So what we are building is we are building the AI hardware engineer. You have the Anthropic, which is building AI software engineer. You have Periodic Labs, which is building AI physicist, and Excelsa is tackling the big problem of building AI hardware engineer. If you think about it, hardware is the next big frontier for AI. And in order to tackle it, AI needs the ability to reason about the physical world. And for that, it needs to understand how to operate in the presence of hard constraints. And we are doing this right now in physical AI's most demanding applications, which is chip design. As we all know, semiconductor chips have become a huge bottleneck for AI. Right? AI is running into this huge physical compute constraint today. But if you think about it, chips actually take about 12 to 18 months to design. That's a very, very long time. What Xcelsa is doing is it's building the frontier models that understand both the math and physics of chip design to significantly compress these design cycles to just a few weeks.
Fascinating. Well, and when I first came into contact with you, I also met with Siddharth and Chinmay, and you all have extremely strong academic profiles. What was the catalyst for the three of you to want to start your own company?
See, the way I think about this is it's actually um, a very rare and perfect convergence of three things that happened when we decided to start this company. First is the market forces. Of course, you have the technology forces, and simply our joint capabilities. Everything has come together at the same time. So on the market side, as we already discussed, there is a huge market demand for specialized silicon, and that goes because into AI applications and even beyond AI applications. And the world needs more number of chips, but also better quality ones than what the existing processes can design. So these need to be optimized for various performance metrics, for example, performance per watt. And we see like a significant amount of investment that is going into resolving this compute bottleneck today. Now, in addition to the market, we have the technology enablers that are also have matured at this point. For example, if you think about AI, in fact, our team was the first to show the world. Now, and this is all the way back in 2023, that AI can autonomously design chips. Of course, it was like a simple chip, but over time, being so close to this particular research frontier, we have observed that the capabilities of models have grown significantly from that time, that now they're able to autonomously design more complex chips. They're able to reason through the physics of these designs and able to iterate these designs more and more quickly. So you have this like perfect technology companion, if you will, that exists that seems almost perfectly designed to resolve the compute bottleneck that itself created. Now, in addition to that, there is our joint capabilities from the team side. Each of the three of us brings a unique capability, and all three of them are actually needed to really solve this really hard technical challenge. So, for example, we have Siddharth, who has deep expertise and decades of expertise in chip design, in AI for chips, and the underlying tools that are used to design these chips. Chinmay, who is our other co founder, has a lot of experience in machine learning, designing domain specific models, and post training large models, and actually using reinforcement learning to fine tune them. And I bring the expertise of optimization, reinforcement learning, And in addition to that, I have a lot of experience actually translating research into having a commercial impact through my previous startups. So the way I see it is just like this, everything sort of coming together at the same time, and I cannot think of a better time to be doing something like this.
I agree, and I almost chuckled a moment ago when you said way back in 2023. That harkens to the pace of innovation and how things have just accelerated beyond anybody's wildest imaginations. And speaking to that, that has also created what was a nascent field, just a couple years ago, the AI-enabled EDA space to becoming an increasingly crowded one, right? And so, what differentiates Excelsa from the masses?
First thing I want to say is that we think of Xcelsa as much more than an AI-enabled EDA company. And the reason I say that is when people think about EDA tools, typically they think about specific solutions that have been designed for specific steps in the chip design process. So chip design process has multiple steps. And each step, there's a specific tool that is designed to automate that step or improve that step. What has happened is when you start thinking about it like this, and you start thinking about how AI can disrupt the space, what most companies have done is they have taken individual steps and they have tried to apply AI to accelerate these individual steps. For example, verification is a very big problem within this industry. By that I mean, you design a chip, you want to make sure that it is functionally correct, is actually doing what it promises to do. And there are many tools that are available, ADA tools that are trying to ensure correctness. And what many companies have done is they have tried to tackle the problem, but now using AI. And all of this have resulted in point solutions. Where Excelsa comes in is, we don't want to think of this as, specific tools trying to solve specific problems. This kind of mindset basically is an artifact of the tools being developed back in late 80s and early 90s when the world was very different. We had to make they had made a different set of assumptions which are valid then, which are not valid now. So for example, it was humans who were designing chips back then. AI was not even a thing back then, right? Plus, these systems are designed to be very deterministic and algorithmic, and they don't really learn over time. So if they see a design once, it's not like they remember that for the next time. Now, AI is very different. So what we're doing is we're saying that, hey, let's not be constrained by how the systems and tools exist today, because they were actually designed with a different set of assumptions 40 years ago. Rather, let's come with like a completely new perspective, an AI first perspective, and ask ourselves, if I were to design the whole stack today, how would that look like? And that's what we are doing. So fundamentally, we are taking an end-to-end approach, wherein instead of focusing on single steps, we're trying to move the whole outcomes. And the outcome here for us is we say better chips faster. Can I actually use AI to design chips that humans cannot design today? And can I use AI to design the chips much faster? Instead of 12 to 18 months, can I reduce it to a few weeks? So that's sort of the goal that we're working on.
Well, extremely exciting. And one of the reasons why I'm such a champion of Excelsa is because of your background with other startups. And you have a very sober minded approach and don't go pounding your chest over just, technical or theoretical milestones. So, can you share with us, without obviously sharing anything confidential, a technical milestone that you and the team have achieved recently that has you most excited, or even a potential customer pilot, without naming any names, of course, that has validated and has just energized you and the team?
Absolutely. Yes, so many things are confidential, but definitely happy to share a few things that we found extremely exciting recently. So, first of all, upfront, I should say that the problems that we are tackling are extremely challenging, and chip design itself is extremely unforgiving. Uh, and AI has a lot of potential, but one needs to use AI the right way to actually solve this really challenging technical problems. Okay. Now, with this sort of having said that, and having taken on the challenge of tackling a very technically difficult problem, I'm pleased to say that recently we've had huge breakthroughs in using our tools to make significant and meaningful impact with our customers. So, as an example, our first product offering in the space is called the Apex platform. Apex is designed to significantly accelerate design iterations in this industry. So when you think about chip design, I said it takes a long time. The question is, why does it take so long? Right? One of the reasons it takes so long is because chips, you don't get it right the first time around. You come up with a design, and the design kind of is functionally correct, let's say, and then you kind of go and measure the performance of this. Okay. And there are many performance measures you look at. One of them is called timing. So, for example, you want the chip to clock at a certain frequency. The problem is that once you have a design, it may not actually achieve the target clock frequency that you want. So, what do you do then? So, you go back, you change the design, you do various things to the design, and then you go back and measure again. Turns out it still does not. And in the process, maybe you've broken something else. And then you keep repeating this process many, many times until you achieve what is known as a closure, like where the design has converged to the targets that you've set for yourself. Right? And this iterative process is very, very slow, time consuming. Engineers try something, they run the tool, which takes a long time. They look at the output, try to mentally figure out using their expertise what to do next. They try other things, and finally it converges. Right? This is a very slow and manual process. What Apex does is it brings AI to significantly accelerate this iteration process. So now AI is basically understanding the designs. It tries to reason through the design, looks at basically what the tool gives it, and figures out here are the best things it can do. It can internally predict the outcomes of various strategies for improvement. And then, without actually calling the tool and using this insight, it can sort of get the right change or the right optimization correct the first time around. So you're significantly compressing this. And we have seen this with our customers on industrial scale designs across two different customers. We have seen that Apex can give significant timing improvements in just a couple of days, whereas the same improvements would have taken the engineers a few weeks to attain.
That's definitely exciting. And, it leads to another reason why I was really drawn to Excelsa is that there's no question. There's two main theses that I've held that are most important. And that one's the democratization of AI and also the responsible deployment and development of AI. And there's no question the democratization capabilities are going to be dramatically expanded. Teams that previously weren't able to design the chips or within the time constraints that they had are going to be free to do so. On the flip side, a growing, a louder audience is now um, has a growing fear of engineers, frankly, losing their jobs to this type of technology. What would you say to that?
Great question. So I think I've always viewed AI as extremely empowering. And I view uh, what we're doing at Xcelsa as empowering a lot of people to actually be able to design chips very, very quickly. So, for example, if you think about the current industry, it's very, it's a little concentrated. There is few companies which are able to design these chips just because it's very, very complicated to design these chips. Secondly, most of the work so far, like if you look at the timeline, most of the chips are tend to be like general purpose chips, like CPUs, GPUs, for example. So that's where most of the compute happens. Now, where the industry has been slowly shifting in the last maybe half a decade to a decade is what is known as specialized silicon. The idea here is that as we have more and more workloads that are coming, and there is a high diversity in the types of workloads that are coming up, we need chips that are specialized to each individual workload to get the best performance out of it. So instead of using like a general purpose, like a CPU, to do all types of tasks, wouldn't it be nice to have a chip that is specialized to each task? So it is very efficient in running that task, and it can happen with very low power, much more efficiently, which is also good for the environment. Now, to enable this, the current process does not allow that to happen. So Xcelsa, the vision that we have, right, is basically chip design is fully democratized. Just like today, you can go type a few words and have a website created. This is not possible even a couple of years ago. We want to have a future wherein you go, you type a few words, you're a biologist, you're a physicist, you're a chemist, you have your own workloads that you need to run. You go, you type in a few words, give some specifications, and then boom, you have a chip that is designed and ready to be fabricated. So that's kind of the future we envision, where everybody's empowered to do this. And we think there is so much demand and so much more we just haven't done or seen that I cannot foresee a future where we are losing jobs. Rather, I see a future where AI is helping everybody do many more things than we can do currently.
I love it. And, switching gears a little bit here. So you talked about how complex chip design is. Maybe the only thing more complex is building a company, especially in this environment. What are some traits that you, Siddharth, and Chinmay look for in terms of building Xcelsa? And also, maybe even equally or more important, what are the things that you look to keep out and that you want to repel away from the company?
As you rightly pointed out, a big uh, like component to being successful is just the team you have. A company is basically the team, right? Like the people that you have in it. And especially for an early stage company like us, it's super important to have the right set of people within the team. Um, so first off, the way we think about this when thinking about team building itself is we are fundamentally very mission driven. We truly believe that humanity needs better chips, and humanity needs this problem solved, and that's sort of the direction that we are going in. Right, we're truly mission driven. We are technically we value technical depth and technical expertise hugely. So we definitely want somebody who have the depth of technical expertise, but at the same time, we want somebody who is curious to about other disciplines. So we are a very interdisciplinary team. We truly believe that to solve this problem, we need a team that has an interdisciplinary expertise. So we have people who are AI experts, we have people who are deep hardware experts, and we have, of course, amazing software engineers all coming together, and whoever is in the team needs to be curious enough to look around, learn from other people, have the humility to know that like there's so much they can actually learn and actually contribute to it. Right. So the interdisciplinary nature is very critical for us. Of course, we need them to be like very collaborative, product driven, and customer needs driven. So that's, I think, one of the fundamental thing we are looking for. And finally, somebody who can actually take ownership of things. So we are, we're a startup, right? So the startup is very different, obviously, from a big company. There's a lot of ambiguity that you need to deal with, and at the end of the day, you need to take a lot of ownership in what you're doing. So that's, I think, kind of fundamentally what I would say. Um, in terms of the qualities that we sort of screen out for, of course, there's a technical component because we are a technical team. For somebody to be a good fit, they need to be have that expertise, the depth of expertise. So, of course, that is something we look for. We look for the fit aspect of it, like somebody who's actually driven to make a difference and make an impact. That is something we look for. And finally, if somebody is a little bit narrow focused, they're like, okay, I'm really good at doing this, I'll do that, but I really don't want to learn or even think about other things. that narrow focus is an impediment in our company. So that's something kind of we try to screen out for. Um, and secondly, just we want to gauge if there would be a good startup fit, like can they handle the ambiguity, and then just be very proactive about things, right? Because we don't make quarterly plans. We just week by week things change, right? Can they just handle that? That's important.
Quarter of an hour plans is the best way to put it. um, as you've experienced, as you're scaling, you've probably seen this, experienced this, that the competition for the talent that you're looking for is extraordinarily fierce. The engineers that you're looking for, the quality of engineers that you're looking for, and leaders are going to be those that are happily, gainfully employed. But to somebody watching this, if you had one shot at telling them why they should move beyond curious about what Xcelsa Labs is doing and engage in a conversation about potentially coming to work there, what would you tell them?
See, the way I think about this is, first of all, one does not need to be unhappy in their current role to be considering opportunities like us. Okay, and the reason is the following. I think fundamentally, everybody, irrespective of what they're doing today, needs to ask themselves two questions. The first is, we are in this unique time, which is probably once in a lifetime kind of thing, where AI is causing seismic disruptions to everything that we know today. Okay. We are fortunate to be sitting here and potentially we could be part of it. The question everybody should be asking themselves is, am I actually doing that? Am I part of this change? Am I one of the people who's pushing this seismic change that is happening? And everybody, in my opinion, should be part of that. It's a once in a lifetime thing. And the second thing everybody needs to be thinking about is thinking about how AI can disrupt what they're doing and how can they actually future proof themselves, right? And everybody should be asking themselves, am I actually doing that? Am I thinking about how AI is going to change what I'm doing? Is what I'm doing today going to be irrelevant tomorrow? And how do I adapt to this change? And I think the answer to all of these basically is, at least right now, at least one of the answers to all of this lies in hardware. Because hardware is that frontier which has not been breached by AI right now. There's so much more to do, and it can have a huge impact on our lives going forward. It is also very, very cutting edge. It future proofs your career, and it's an exciting area to be in today. So if somebody is thinking about this, I would try to make the case to them that look, if you have any connection to hardware, you should be doing hardware, and not just any hardware, AI-enabled hardware. Like, how do we think about how hardware engineers should behave, right, in the future? Like, how can AI completely disrupt that? And once that I'm able to convince them, then the next step I would say is, okay, now that you've, let's say, agreed that this is something you should be doing, then Xcelsa is the right fit for you. We are the right fit, in my opinion, at least, because we are a very, very credible team in this space. There are very few such credible teams in the space. We have a ton of experience doing these types of things in the past. We come with like a lot of credibility and deep expertise in this domain. Plus, we offer opportunities to truly create impact at very, very big companies very quickly. That is not otherwise possible. Um, so that's sort of at least how I would think about it.
I'm really curious. 4 to 5 years from now, if you were to look back, what hope or what do you hope the impact that Xcelsa Labs has on the industry will be?
Great. Look, I think the big vision we have and the big thing we are pushing for is hardware at the speed of software. So if I can look back 5 years later and kind of see a future where hardware is being built like we build software today. What would that mean? It means that a hardware engineer is going and interacting with the system using natural language. They are basically specifying their intent and their targets to the system. The system goes, and it automatically figures out what to do next. It doesn't. It can run several jobs in parallel, and it really understands the design intent as well as the physics of the problem. And things are not necessarily happening sequentially. So right now, by the way, things happen sequentially because not for any physical reason. It's just because that's how EDA tools were built. There's no reason it to happen in that sequence today, by the way, right? So you have an orchestrator, AI orchestrators can automatically figuring out what to do next, running things in parallel, and surfacing the right information to the engineer so they can make the next best decision. And most importantly, a system that is constantly learning and getting better over time, which is a crucial thing that's actually not happening today. And then all of this comes together, and we are seeing actually significantly better chips, what we call superhuman chips that are coming out and disrupting and impacting us in a better way. And that's sort of the future at least we are hoping to see.
Well, you had me at hardware at the speed of software. I love it. And I have a feeling that we're going to be speaking again in this format again in the very near future. So I won't say goodbye. I'll say until next time. Really appreciate your time.
Thank you. Thank you so much for having me.